Since we'll be using a lot of groups, let's start finding some of the groups on this model. Now, if we were to try to balance this model, and we could do that either from this button on the toolbar at the top to balance the model, or if we were in the loads dialog here, we could click on the balance tab. And I take that back. This doesn't actually do the balance. It'll tell you what the emergence, heel, and pitch are, and you can set them in here and specify where you want your water plane to be. But when you do the float for this still water condition, it'll enter these values for when it's in equilibrium. But you could also override that equilibrium condition and specify a specific water line in here if you wanted. Now, if we try and float this model, we get a fail to balance. Well, there's a couple reasons for that. Now, we did yesterday set the wettable elements and we set the pressure side appropriately. So we do have all of the elements to apply a load to. But if we go back into the job information, this I button in the upper left, you'll see we haven't put on transverse symmetry yet, and we've only modeled half the hull. So we're going to want to do that so that we get a full model. And if we come into the parts tree here, and we can get a quick estimate of our structural weight by right-clicking and selecting Show Weight, and we can see we have no weight in this model yet, since we haven't assigned any properties. While there is a default steel, none of this plate that we've imported has any thickness. So first thing we'll want to do is go ahead and create some properties. And we're just going to assign some very simple properties to the hull just to get something that we can work with. So we'll use 2 different thicknesses of plate and 4 different types of beams. For the plate thicknesses, the easiest way to create these is just click on the library, and we can create, let's say, some 19mm plate for our main deck, and for our standard hull plating, we'll use, say, 14mm. So now we have 2 plate types available here. And for the beams, you can see as we imported each module, it created a new null beam type, and we'll clean this up after we have assigned the properties. We can get rid of these. Now we could consolidate them all into the same beam type, since they all have similar properties, same web height, thickness, flange, and material, but we'll leave them separate so we can select things by property when we go to use the group modify to assign these properties. Again, we'll use the library command to bring in the new beams. Now we could manually define them using the web height, web thickness, flange width, flange thickness, and the material, or you can simply open the AISC shapes database, and you can find that under in the installation directory for Maestro, program files, Maestro system. Just open that CSV file, and I'm going to make this a little larger. So we'll scroll down to row 95, and we'll add the 127 by 76 by 7.9 angle. Scroll down to 111, and we'll add that 102 by 76. And we'll come down to, let's say, 160, and we'll have this 500 by 111. And we'll use that for our main girders along the decks. And go down to 214, and we'll grab this 380 by 67, and we'll use that for our frames. So those line items, again, if you're following along, were 95, 111, 160, and 214. So if you add those to the right-hand side and hit OK, they'll be added to our available beams. So for assigning the properties, we can quickly assign everything. As I mentioned earlier, we're going to use that heavier plating for the main deck, and everything else will get the thinner plate that we created. So we just create a general group here. You have to click on the ID to generate one before you can add elements to it. And then click in the dialog window here and then select one of the elements. And we can say add by property. We could also do add by type, but that would only add all the quads. Then we'd have to select a triangle and add all of those. If we add by property, it's going to add every element that's using that type of steel. And you can see it didn't add the beams. It only added the plate elements, but it got all of the quads. And if we click on that, you can see all the quads and the tris. And now we can use the modify properties command. And we'll select we're only changing plate here, but we'll assign that to the 14 millimeter plate. And then we'll reassign the main deck. Just grab one element there and use add by seed. And it'll search out on the main deck, adding all of those quads and tris. And we use modify properties again, change the main deck to the heavier plate. So now if we view by plate property, see we have two different types defined. If we now click on show weight in the parts tree, we have 1.2 times 10 to the 6 kilograms defined from our structural weight. We zoom in on the deck here. We can grab, and let's do this by whole module. I'm going to grab one of the deck stiffeners here. And we're going to set, I guess, all of our deck stiffeners to be that 120. $127. And then similarly, we'll grab the frames here. I accidentally grabbed the decks, so we will, and it wouldn't matter, we can leave the decks in there, because if we do group modify and we're only assigning beam properties, we're not changing the plate here, we're only assigning beams, so we'll ignore any of the plating. But we will assign our frames to be WT380. Since we grabbed a module, this is a graphics issue in Maestro. Whenever you add something by whole module, it makes it invisible, even though it's still shown as being visible in the parts tree. So if we come over here and say visibility on, it'll bring them back into view. The Maestro graphics are built on a very old Hoops graphics library, and that is a carryover in the graphics, which are, I guess, a little difficult to work with in terms of updating the code. So let me change our view style to show the beam properties. We still need to assign our bulkhead stiffeners. So we've got the deck frames and stiffeners assigned. So here we'll grab the bulkhead forward and aft frames, and we want the longitudinal bulkhead stiffeners as well. We can modify those beam properties, and we'll use the 102 on those. For those frames on the longitudinal bulkheads, we'll assign those to be the same as the frames on the deck. And actually, here's another thing that's very handy when you're assigning properties. You don't always have to go into the modify properties dialog and select this and use your drop list for the beam type, because sometimes this can be a little bit of a pain when you have a very large model and a very large number of beams. Searching through that list can be a little difficult, and sometimes if they're all mixed up, it's sometimes easier to come into the properties dialog here, look at all of the beams that have been defined, and I have another model with several hundred beams in here. So I'll sort them by web height, I'll find the one I want, and I'll note what the ID number is. And if it's, say, beam number 211, it's much easier when I come in here and go to modify properties to select it by the ID number, go down to 211, than to scroll through the list of properties by name trying to look for it. So that's one instance of when using the ID numbers can sometimes be a little easier than the names. The other thing is, since I know I've already defined the deck frames and I want these longitudinal bulkhead frames to match those, I can switch over to element here and select one of the deck frame elements. And then when I right click in here, rather than modify properties, I can say assign same property. And what it'll do is the one that's highlighted, that last one that I selected, it's a beam. So if I say assign same property, it's going to assign any of the beams that have been selected, like in that other module. It won't affect the plate properties, but any beams that are in there will get the same property as the one that's highlighted. And if I turn visibility back on, you'll see the bulkhead there. Refresh, they're the same size as the deck beams. And I still need to do the hull frames and stiffeners. So we will use hull module. We'll grab the, and as an example, right here, I have the hull selected. So all that hull plating is selected, but I'll come in here and just grab one stiffener and say assign same property. And when I turn visibility back on, my hull stiffeners have been updated. And if I were to switch over to viewing the plate properties, you can see my hull plating was unaffected. And the last thing we need to do is the hull frames. I just grabbed one. I wanted to grab the whole module. And again, we'll switch over to add a single element, and we'll add one of the other frames and assign by same property. We can turn visibility back on and refresh so that it redraws. And that should give us a sort of baseline model. We should have properties on everything. And a quick way to check that is we can view, instead of by the beam or plate property IDs, we can view by material type. And right now everything is common steel. So that actually wasn't what I was trying to do. I was thinking the originals were a null material, but they weren't. They were using the ST24. But if we come into beam properties here, we can see that the only beam properties that are in use right now are 10, 11, and 13. So I actually didn't assign some of them correctly. I didn't use 12. Oh, those are my girders. I have not assigned the girders yet because I had all the deck stiffeners were assigned as a group in a single module. Where I wanted my deck girders were going to be on center line and at 5 meters out. 5 meters out is also where that additional longitudinal floor is in the inner bottom. So the easiest way to do that is, again, using the group dialog, the group modify. So we'll hit the ID button to make a general group. And I'm just going to grab one element from the center line on each deck. I accidentally got a quad there, so I'm going to want to put that quad back. So we got the center line elements on those 3 decks. We'll grab the center line element on this app. And we'll need the one in. Actually, I'll have to check that. I'm not sure if it was the 5th one in on my other sample model or not, but for now, we'll go ahead and use the 5th one. We just need one element to act as a seed. We don't need it on that apps one because there's actually a bulkhead there. Now, if I only select one of these and I say add by seed, it's only going to use that one beam element, and it'll search fore and aft on that one. So what I want to do is select all of those beams that I put in here, all 8 of them, have them all highlighted and say add by seed. And that's basically the same as if I were to click on each one at a time and say add by seed. And you'll see that it went and it searched fore and aft and added those to the selection set here. And now I can modify properties, and I know I want beam type 12. That's the WT500. Now these two greens are a little similar. So between my frames and girders, you can tell them apart, but if I wanted to be a little more clear, you can right click in the background here and say random color, and it'll change them. Now I went from 2 greens to 2 blues, so we'll do it again. Sometimes it takes a few tries. Now we got a light blue and a dark blue. The other thing that I didn't do, and this will, I guess, have a greater effect later when we go to define evaluation patches, and that's, not so much with the model loading, but when we go to do evaluations, we'll need to create evaluation patches for checking buckling for the columns and the stiffened plate. And all of our beams right now are all considered stiffeners. If we go into our beam properties and list them, you'll see the beam types are all stiffeners. But we do have the option of making them stiffeners, frames, or girders. To view them graphically in the model, under ID, where we say beam property, you could also say stiffener, frame, or girder. And if we select frames, you can see there's nothing defined, although we know we have frames in the model. So we come in here and we'll go by ID and we'll check stiffeners, and now they all show up. So let's go into our beam properties, and we will modify the ones used as frames and girders. So this 500, the WT500, is where we're creating our girders. So we're going to switch that from a stiffener to a girder, and we'll say modify. And I had highlighted it in the table down below, but what was still selected up above was the null beam property. So when I hit modify, all I changed was the null beam property to be a girder instead of a stiffener. So it doesn't matter what you have highlighted down here, it's what's selected up above. You can either, in the drop list, change it to the WT500, or if you double click down here, it will update on the top line. And now I'll make that WT500 a girder, and I'll double click on the WT380, and we'll make that a frame and hit modify. So we have 2 stiffener types, a girder type and a frame type. And now if I go into the view by ID and I select frames, you can see all of my frames are colored in the model, and everything else is gray. If we check our girders, we can see those are in the appropriate locations. And if we check our stiffeners, well, they're a little small, but they are in the right spots. So now we have all our baseline properties applied. And if we check our weight, 1.6 times 10 to the 6 kilograms. Now, if we try and do the hydrostatic balance, you can see it's computing something in here, and it did find the mean plane normal. If we switch over to the output window, you can see a little more of what exactly it had done. So these are the various iterations that it went through to go ahead and balance. So it's load case 1, and it just had balance cycle 2, 3, 4, and I think it allows up to 20 before it gives up, but it found it after the 11th cycle. And it tells you what your trim angle is, the PMT, BML, the forward and aft drafts on center line, and at the, I guess, outer extreme. We did run a balance on this earlier, and if we want to see where that water plane showed up, we can turn on our water plane, and you can see it's floating pretty high because there's not a whole lot of structural weight in there. So we're going to add some additional weights from some of the various loads, and then we'll do the rest of our distributed weight for all of those other items in the hull for electric piping, furniture, and so forth.